In the last lesson, you saw trinomials where the a value, or the leading coefficient, was 1. Not all trinomials have a leading coefficient of 1, so in this lesson we're going to look at how to factor those types. While we're going to end up with the double bubble answer, the way that we get there is different. So there's two ways to do it. One is by using guess and check, which is very time consuming, especially if you are new to factoring. But the other way that I encourage newbies to do is I encourage them to use this method called splitting the middle. So here's how splitting the middle works. You identify your A, B, and C, and then you multiply the A and the C values. Similar to what we did last lesson, you make a list of factor pairs, and then you pick the pair that adds to the middle term. So kind of similar. Then what we do is we split the middle term into those two terms that we just created using the factor pair. Then you use your GCF factoring technique to factor the first two terms. And you use your GCF technique to factor the last two terms. If you've done it correctly, the terms in the parentheses should match. So how do you end up at your double bubble answer? One binomial is the one inside the parentheses, and the other binomial is the one outside the parentheses. All right, so there's a lot of steps, so let me show you how it works. So in the last lesson, we would just take out factor pairs of 7. But in this case, we have to take out factor pairs of 2 times 7, which is 14. So I'm going to make a list of factor pairs of 14. I have 1 and 14, which is obviously not going to add to negative 5. But if you do 2 and 7, they'll make 14. And then I actually want to get negative 14. So it's going to be negative 7 and positive 2, right? Because I have to multiply to a negative, and I want the 5 to also be negative. So when I add them, the 7 has to be more powerful in a sense. So then the next thing that you do is you take your factor pairs and you replace negative 5x with the pair that we just found, positive 2, negative 7. So here's what that would look like. 2x squared, and then I would do minus 7x plus 2x minus 7. So I just took this trinomial and I just replaced it right here with negative 7 plus 2. Don't forget the x, or whatever the variable is. Okay, so now you factor the first piece using GCF, just those first two terms, and they actually just have an x in common, so that's all you have. So you get x times 2x minus 7, and then you do the GCF of the second terms, which is actually just 1, so I get positive 1 times 2x minus 7. I know I've done it correctly because these two binomial pieces match, so one binomial is x plus 1. Because that's what's outside the parentheses. And the other binomial is the one that's inside the parentheses, 2x minus 7. Kids will say to me, how come you only wrote 2x minus 7 once? And it's because the second 2x minus 7 is actually kind of just checking that this is the correct binomial. So you have the outside ones from x and plus 1, and then you use the 2x minus 7. You can double check by multiplying these to make sure that you get your original trinomial. If you want to pause and do the rest on your own and check, you can. If not, follow along. For this, I'm going to do factor pairs of negative 20 because that's what A times C is, right? Okay, so I want to get negative 19, so I can tell right away it's going to be negative 20 and positive 1. So I'm going to take my original trinomial, 4x squared, but now I'm going to do plus 1x minus 20x and then plus 5, or minus 5, I'm sorry. It doesn't matter which one you do first, but I'm going to show you what happens when you do the second one as negative. So the first GCF right here is just x. So I get x times 4x plus 1. And then the second GCF is negative 5. If this first term right here, this first term in the second half, right there, if that's a negative sign, you have to factor out a negative coefficient. If you don't factor out a negative factor, then the binomials won't match. So if you want to write that down, I would definitely encourage you to do that. So I get minus 5, and then when I factor that out, I get positive 4x plus 1. So you see, if they didn't match, then I'd have to do it again, but they do. So the final answer is x minus 5 times 4x plus 1. All right, let's look at the next one. I'm going to do factor pairs of negative 72. Let's see, I think it's 9 and negative 8. That makes sense to me. So let's see what happens. I get 6x squared. I'm going to replace it with plus 9x minus 8x. And actually, you know what I'm going to do? I'm not going to do that. What I'm going to do is I'm going to put the negative one first, so that way I don't have to factor out a negative coefficient. So minus 8x plus 9x minus 12. All right, now I do the dividing GCF. So the GCF of this first half is 2x. So I get 2x times 3x minus 4. And then I do the GCF of the second half, which in this case is 3. So I get plus 3 times 3x minus 4. All right, one binomial is the outside terms, 2x plus 3, and the other binomial is the term inside, which is 3x minus 4. And as always, you can multiply these out and confirm that you get the original trinomial. If you have any questions, write them down and ask me when you come to class.